2 and 1. All right, so welcome. So this is basically a test on kind of line segments, lengths of a line segment, you know, relating it back to triangles, 3 points, circles, equation of circles, you know, so it's kind of geometry, I guess, per se. It is a topic covered in grade 10. I think this test will kind of force you to figure out certain things that maybe will go beyond what you would normally do in grade 10, and I hope that you can download the test, try it out on your own, really test yourself. So you can find the test in the show notes and you can click on it, download it, do it, and then come back to this video where I'm going to walk through the solution to all of the questions. All right, so let's get started. So question number 1. So here it is. Okay, so it's a long question that you have here. I'm going to go through them kind of one by one, and we'll figure out what we need to do. So we have 2 points, point 1, point 2. First it says find the equation of the line constructed by the 2 points. So that shouldn't be a problem. You know, you should have been able to do that in grade 9. So let's do that construction first. So whenever you're constructing an actual line, of course, you're going to have to find the slope. So slope is rise over run. And in this case, so y2 minus y1 over x2 minus x1. So that is pretty simple. So here is your y, so your rise, and then here is your run that you have. And this comes out to 7, so this is going to be 7 plus 4, so this is 11, and 11, and this is going to be -3, so I'll put the negative in front there, doesn't matter where it goes. So that's our slope. Great. Once we have our slope, we can take the equation of the line, so y is equal to mx plus b, substitute the slope, substitute one of the points, and then we can find our y-intercept and we have our line. So I'm going to take, let's say, that first point there. This is going to be, now the slope is kind of ugly, so be it. This is what we have. In this case, you'll see that these numbers aren't really the nicest that you have. So let's work through them. So this is minus 22 over 3 plus b. Bring this guy over on the other side. And we will have -4 plus 22 over 3 is equal to b. So now we can find the lowest common denominator between them. So that's going to be, I guess, 3. So we have -12 over 3 plus 22 over 3 is equal to b. And our b is going to be, so -12 plus the 22. So that's going to be, I guess, 10 over 3. And now we have our equation of the line. So we have -11 over 3. And this will be x plus 10 over 3. And that's our equation of the line. And those are our 2 points. Now what I'm going to do is I'm also going to start graphing these things so that you can see it. And so we'll have y. I'm going to use Desmos as I normally try to do. Encourage you to go on desmos.com. So this is going to be -11 over 3 x plus 10 over 3. Now I will put restrictions here on the x because it's only going to be between the 2 points. So notice that this is between these 2 points. So between the x values, so x is between -1 and 2, right? So that's going to be the line. So I'll go back here, and this is going to be, so -1. This is going to be x, and it is 2. So it is between those 2 particular points. So those are the actual points. Now let's plot the points. So this is going to be the 2 points, 2, -4. And the second point is -1, 7. -1, 7. Let's put that, let's label them on. All right, so let's go back to the question. So we have part A completed. Now part B says find the midpoint of the line segment created by the 2 points. All right, well, the midpoint is basically the middle line or the middle point. So in order to do that, I mean, I can just get it actually right off of here. So the midpoint, so on the x, right? So we have to add the x values to get the midpoint and then divide it by 2. All right, so in this case, it's going to be -1 plus the 2, which is going to be just 1, divided by 2. So that's going to be 1 over 2. That's the x value. The y value, we're going to be adding up the 2 y values. So it's going to be -4 plus 7, which is going to be 3. And 3 divided by 2 to get the midpoint. So that's going to be our midpoint of this particular line segment. Again, I'm going to graph it so that you can see all of this happening kind of in real time. And so that's going to be the next item. So 1 over 2, that's the point, and then 3 over 2, that's your second point. Let's label it there. And notice that indeed, so if you can see it on the screen there, that is the midpoint, right? So it's the middle point of the line segment. So that's that. Find the length of the line segment. So in order to find the actual length, how long it is, then, we have to take the 2 points. So in this case, I'm going to just take these 2, I'm going to start working with them at the bottom. All right, so this would have been the next part, which is, I guess, C. Let's put this in here. All right, those are the points. So now, how do I find the length of the line segment? Well, the length of the line segment from these is nothing else but simply making sure so that because you're taking this, you're going to take the x length, right? Square it. You're going to take the y length, square that, and then take the square root of that. So we're basically using the Pythagorean theorem in the x and y coordinate system. Okay, so that's how we actually have to take it. So my length is equal to, it's going to be the square root, all right, that because it's a squared plus b squared equals c squared, right, from Pythagoras. So now the x values that we need, so let's take P2, so that was -1 minus 2, square that, plus now 7 minus -4, and square that. And what do we get? So it's -3 squared, so that's going to be 9, plus 7 plus the 4, which is 11, 11 squared, which is 121. You can check that if you like. And that is going to be your length. All right, so your length is approximately, if I take out the calculator, okay, so it's going to be approximately 11.4. So approximately 11.4. Okay, so that's going to be the length between the two. So here, notice that that's the length between them. All right, so now what's next? So the next question, or the next part of the question, says find the equation of the right bisector. So this is basically the perpendicular bisector to this line segment. Now, what does that mean? A right bisector means that it splits the line segment in half. Now, we already have the midpoint, so it splits it in half, and then it's perpendicular to that line segment. Now, we know the slope. All right, so here's our slope. So for the right bisector, right, the slope is simply the reciprocal, the negative reciprocal. So if you take the negative reciprocal, it's going to be 3 over 11. The negative is gone because you're taking the negative reciprocal. So that's our slope, okay? So now we have, so this is going to be part D. So our slope is going to be 3 over 11. Now, the point that it's going through, it is the midpoint. Now, the midpoint we found, and that was 1/2 and 3 over 2. So this was 1/2 and 3 over 2. So that's the right bisector. It has to go through those. All right. So now, from our equation, y is equal to mx plus b. So So now this is going to be 3 over 2 is equal to our slope, which is 3 over 11. Our x value is a half plus our b. So what do we have here? We have 3 over 2, and this is going to be 3 over 22b. Bring this over to this side, and we have 3 over 2 minus 3 over 22. This is b. Now finding the common denominator, in this case I guess it's 22. So now how do I get to 22? Well, 2 goes into 22 11 times. So it's going to be 11 times 3. That's going to be 33 minus 3 over 22, and that's your b. And now once we do this, so this is going to be 30 over 22, that's your b. You can reduce this. It's going to be 15 divided by 2, 15 over 11. That is y is equal to 3 over 11x plus 15 over 11. Let's graph this. Let's put it up here. So y is equal to 3 over 11x plus 15 over 11. And there we have it. Here's your right bisector. So it cuts it in half, goes through the midpoint, and is perpendicular to it. So that's what we would do for that example. Now, what else is remaining? If I go back here, so E, so find the shortest distance from the point 1, 1 to the line going through the 2 points. Okay, so now, so the point 1, 1, let's graph it so that you can see it. So point 1, 1. All right, let's label it there. So notice it's not very far. Now, what is the actual distance? Well, the distance is going to be, we need a perpendicular line to that original line segment. So that's what we need. We need to find a perpendicular line, and I'm going to have to find the point on that line segment. And then once I have that point, now the nice thing is I already know what the slope is because I had it from the right bisector. So the right bisector, the slope was 3 over 11. So in order to find, let me go here. So this would have been the last item. This is E. So we have a 0.11. We know that the slope is 3 over 11. So this is going to be y is equal to 3 over 11 x plus b. Substitute. Now luckily this is going to be 3 over 11. Bring this over to the other side. 1 minus 3 over 11 is equal to b. Okay, so now 1 is just 11 over 11. So 11 minus 3. Okay, so this is 11 over 11 minus 3 over 11, just so you can see where it's coming from. That's going to be 8 over 11. That's your b. So y is equal to 3 over 11 x plus 8 over 11. So that is our new line. Okay, so let's show you that. Y equals 2, so 3 over 11. We already know that's going to be perpendicular. And plus, and that was 8 over 11. 8 over 11. Okay, so there you go. Okay, so that's the line. Now, I need this point. I mean, I can cheat here because I can get it off of the actual chart. So that's going to be the point that we need, right? And then we need the distance between them because we want the shortest distance between that point and then the line segment. So in order to find this point, sure, I mean, you can plot it, but on your test, most likely you wouldn't be able to plot it. So you would be stuck. You would have to take this line and the original line, right, which was, so this line right here. So we need those two. I'm going to cut this out, copy, bring it down. Okay, so I have these two lines. Now, I need to find the point of intersection between these two. That's what I'm going to have to find. All right, so now in order to find the point of intersection, so I mean, I guess I'll do it. I will equate the two lines, find my x value, find my y value. So I'm going to do that in fast forward fashion here. Okay, so welcome back. So that's the point. All right, so I solved for x by equating the two lines, substituted to get my y. Now 43 and 59, let's plot it here. So it's going to be 43 over 65 and 59 over 65. Oops. Label it. Okay, so there you go. So notice that's exactly that point of intersection that we have there. Now that you have those 2 points, well, we just need to find the distance between the 2 points. And in order to find the distance between the 2 points, so this is just length of the line segment. So we have 2 points. One point is 1, 1. The other point is there, and we need to find the length between these two. So you would be able to find that out. So the actual length, which is the shortest length, would be, again, so square root of, right, let me substitute it all in, and then I'm going to round off the answer. Okay, I'll do that in fast forward fashion. All right, and there you have it. Okay, so that would have been the length of that particular line. So it's square root of 8 over 65. Back here, okay, it's not very far away. All right, so from that, that is just simply that particular distance that we have. Okay, and that was all of question number 1, which, as you can see, is a lot of work, but it forces you to understand quite a bit of information and probably takes you out of your comfort zone. You know, do you really understand this stuff or not, and then what to do. Here's question number 2. So take the following 3 points, P1, P2, P3, and state what type of triangle can be created from the points. Now you may recall that if you're working with triangles or quadrilaterals in coordinate systems, you can actually tell what type of triangle it is. Is it an isosceles triangle? Is it a right isosceles triangle? Okay. Is it an equilateral triangle? You know, if you have quadrilaterals, there's different types, right? There's trapezium or trapezoid. You have rectangles, you have squares. Now, if you've forgotten how to identify those things, I'll put up a link up above, so you can check that video out, which was part of this chapter. Now, let's try to see what we can do. Now, we're going to take the 3 points, and then we're going to see what kind of triangle it is. Now, if for triangles, the easiest thing to do is, I mean, if you can graph them, great, so you can see it visually, but then don't get fooled. But you want to be able to find out the lengths of the triangles. That's one of the first things. And if you notice that all the lengths are different, well, then it's just a regular triangle, right? It's just all irregular, so that we have. But if you notice that 2 sides are equal, then it might be an isosceles triangle. And then you can see which isosceles triangle it might be. You know, is it a right isosceles, meaning that is the angle between the 2 sides at 90 degrees? So then you can check if the 2 slopes are perpendicular to each other. Now, if, for instance, you have all 3 sides are equal, great, then it's an equilateral. So we're going to try to do that within this example. So I'm going to first just simply take all of these and try to see what type of triangle that we're going to get. I'm going to take P1 and P2 and find the length. This one should be easy. P1, P2. So find the length here between them. Notice that the x value, so it's negative, it's going to be negative 8 minus 0 squared plus 0 minus 0. So that's just great. It's going to be the square root. This is going to be 64. So this is just equal to 8. Okay, fantastic. So that's what we're looking for. We want to be able to see now. I'm going to take P1. So let's say P1 and P3. So let's see what that gives us. What's the length there? P1 to P3. So this is going to be 8. Okay, we have 2 sides that are identical. So this could be some kind of an isosceles. All right, let's try the third one. We'll try P2 and P3. An equilateral. So this is an equilateral triangle. Why? Because all the sides are the same. That's why. And that's exactly what they were asking, right? So now take the line segments from the triangle and graph them. So you can certainly graph these, you know, we can graph all the points. All right, so let's go back here. Now, square root, you'll find, so notice that the keyboard there, so if you go back here, it's popping up there. So I have a square root symbol that I can do there, 48. All right, so we'll do that and then we'll label them. Okay, so that's what we have here. And that is our equilateral triangle there. Now you can, I mean, if we graphed it, it kind of would look like it's equilateral triangle, but of course we have to check it for ourselves to see. Now, if you want to graph it completely, you can now take any of the 2 points, draw the lines. So the one at the bottom is easy. The one that goes on the sides is not as easy, but I'll leave that with you. All right, so you can graph those in there. All right, and I'm going to do it in fast forward fashion, okay, so that I can show you the 3 lines. So I'll be right back. All right, so we'll graph them up. All right, so welcome back. So I ended up finding all the slopes and then the y-intercepts. So you can do that directly, as you know. I didn't really round anything. I kept the radicals in there. So here's one of the lines that you see here. All right, that's one line. Here is the other line. The third line was just flat, y is equal to 0. So that one was the easiest one. That's this one right here. Now I put restrictions on all of these lines so that, you know, if you graph it out, here are the lines using Desmos. Notice the restriction on the first line, y is equal to 0. It's between -8 and 0. That's the x value, so that it doesn't extend further out. But those are all my lines. And notice that it creates this nice, beautiful equilateral triangle, which is pretty neat. And that is it for that example. Question 3. So we're going to take the triangle from the previous question, so that equilateral triangle. And now it says show that the altitudes, medians, and perpendicular bisectors. All right, so altitudes, medians, and the bisectors all meet at the same point, the centroid. Does this mean that the orthocenter, circumcenter, and the centroid are all the same point? Now that is actually a property of equilateral triangles, that indeed they will be meeting exactly at the same point. Now, you may not run into it unless you have seen it somewhere. Now you have to understand what altitudes are, what medians are, and what perpendicular bisectors are. So let's go through those first. So what I'm going to do is let me just capture. All right, I'll take this screen shot to try to teach you or refresh you back on. So let's say this is my image. I'm going to put it back into, so let me add it. And here we have it. Okay, so first off, what are altitudes? So altitudes, okay, are created from a vertex of a polygon that creates a 90-degree angle with the opposite side. And as you can see here, so my altitudes, try to switch the colors here. So here's from one of the vertex. Now 90 degrees is going to be straight down because it's an equilateral triangle. So it creates this. Now that's an altitude from that vertex. Okay, now medians. What are medians? Medians are from a vertex to the midpoint of the opposite side? Well, this is exactly the same thing, because the opposite side, the midpoint, is right here, right? It's at -4, 0. So that is the median. So the altitude and the median are exactly the same. Now the perpendicular bisector, notice, of that side would cut that line segment, so this line segment, in half, which we know is the midpoint, and then would be perpendicular to it, which again is exactly the same thing. So all of these are the same. Now what we would have to do is, okay, because we know these, if you do that to every single side, you're going to get same thing here. So this is going to create, so another 90 degree right there, and then this is going to create another 90 degree right there. And notice that there's only one point of intersection, and that indeed is the centroid of a triangle. And because it's an equilateral triangle, this question is actually not very difficult. It falls out from the properties of equilateral triangles, that all of these are meeting only in exactly the same point, and that point is going to be known as your centroid. And your orthocenter and then your circumcenter that you have, right? Orthocenter is coming from the intersection of altitudes, and you can take a look at the video if you've forgotten altitudes in the orthocenter. I'll put a link up above there. The circumcenter, right? So the actual circumcenter comes in from the intersection of your perpendicular bisectors that you have, and I'll put up a link on circumcenter up above there, okay, if you like. And then the centroid is where the medians are all intersecting. So there we go, we have all our mediums. So they're all the same, and it turns out that we can actually create the equation of a circle, and it will go through every single point that we have. So that is it. This is a great refresher. Now, if we have to prove this and show this, so how would we do that? You can take any of the two, because you only need two lines. So you can take any of the two lines. So one of the lines is very nice and easy. So it's this one. It's just simply x is equal to -4, because it's just a vertical line, right? The slope is infinite there. So that's one line that you have. And now you can find one of the other lines if you like. All right. And then equate the two and find out where they actually intersect. So I will do that. I'm going to find, let's say, so what I'm going to do is I'm going to find first the midpoint right here. Okay, and now I have this point and this point. I'm going to create this line. So I'll find the equation of that line, and then I will find where that centroid is. All right, so let me do that. So first, the midpoint of those. So now the midpoint of the lines. So what I had was, I have -4, and then this was the square root of 48, and then this point was 0, 0. So the midpoint is, so this is going to be -2. Notice I'm adding the x's, dividing by 2, and then this is going to be 48 divided by 2, right? So adding the y's. So that is my midpoint. That's this point right here that I have. Notice it is at -2 there, and then it goes up. So that's what I have there. Now I have the 2 points, so -8, 0, and I have the -2, 48 over 2. So let me find the slope, and then let me find the b. So I'll do that in fast forward fashion. All right, so welcome back. So there you go. So that's the line that goes through. So I just graphed it up for you. And here's what I found it. Now, there is an easier way to do it. Don't forget that because we had already found the equation of, let me go back here. So we already know, okay, we already know this. We know that the line we're looking for is perpendicular to this. So we can just take the negative reciprocal of the slope, and then it's much easier to find that line that goes through that. So now that I have the lines, and so x is equal to -4, so notice x is equal to -4 is the other line. If I substitute that in here, I'll get the value of y. So y is going to be equal to 1 over -4 plus, this is 8 over square root of 3. And that's going to be your centroid. So your centroid is going to be at -4, and then whatever value this comes out to be. And I can leave that for you if you want to be able to find out what that is. All right, so that was question 3. Question 4. Take the following 3 points and create an equation of a circle that passes through all 3 points. Graph the circle and then the triangle made up of the 3 points. All right, so the graphing will be a little bit of a pain. Now, how do we find an equation of a circle that passes through all 3 points? Well, this is basically testing you. How well do you understand, or how well do you remember the circumcenter? Circumcenter. Now, for your circumcenter, what happens is if you have a triangle, if you find the perpendicular bisectors of that triangle, they will meet at the circumcenter, which is the center of the circle that will go through all the points that you are given. That's what will happen. Now, of course, the points can't line up in a line or something like that, because otherwise you wouldn't be able to create a circle. But let's take a look and see if we can find the circumcenter. And then the other property of the circumcenter is that the distance from that circumcenter to each point is equivalent. It's the same. And it has to be the same because if all of those points are on the circle, then that means that distance should be the radius to each of those points. And that's what we have to find out. Okay, let's get started. Okay, so here is our points. So what do? I need the perpendicular bisectors to all of these, which is going to be a lot of work. So we need P1, all right, so to P2. So that's going to be one of the sides. We're going to have, okay, so here P1 to P3, that's the other. And then we'll do the last one, which is from P2 to P3. Now I need to find the perpendicular bisectors, which means I need to find the midpoint between the 2 points and then find the line that goes through. Now, remember, okay, you only need to find 2 of the perpendicular bisectors because you're guaranteed that the third one will go through. So it won't be as much work as we may think. Now I will graph this and then we're gonna go along and try to see how this whole thing looks like. So I'll take you step by step to solve this example. How this will look like for us. Those are the points. Now I need just 2 of these. And let's take a look. We'll try to find out. We have -2, 3, and 0, 5. So that's our first line. So we need to find the slope. So slope, so 5 minus 3 all over 0 minus -2. It's going to be 2 over 2, which is 1. Great, that's the first slope. Now I need the perpendicular bisector, so I don't need that line, I just need, okay, the opposite. So that means the perpendicular bisector, so the slope of that is going to be -1, right? Because it's the negative reciprocal of that. Now, that's that. For my second one, so which one is easier? P1, I'm going to take P2, P3. I don't know if it's easier, but let me take P2 instead here. P2. The reason is because it has a 0, 5. So this will be, all right, so P3, so 4 minus 5. And so that's 4 minus 5, and then 1 minus 0. Okay, that's my slope. This is going to be negative 1, 1. Huh. Okay, so this worked out great. And then the negative, so this was this. So negative reciprocal is just going to be 1. So those are nice slopes that we will have. And now we need to find between P1 and P2, we need to find the midpoint, right? So what is the midpoint? So the midpoint here, that's going to be the point that that line has to go through, that perpendicular bisector. So the midpoint will be, so the x value is 0, negative 2 divided by 2, which is going to be negative 1. Then we're going to have 5 plus 3, which is 8. 8 divided by, so this is going to be 4. So that's the midpoint. So that's that one. Now the midpoint on this side, what do we have there? The midpoint is, we have, so that is we have P2 and P3. So the x value 0, 1 divided by 2, so it's going to be 0.5. 0.5 or 1.5, or sorry, 1/2. And then 4 plus 5, so that's 9. 9 divided by 2, so it's going to be 4.5. Okay, so now let's find the actual equations here. And those equations, so I'll find the intercepts. Let me do that in fast forward fashion. Here are our lines. These are perpendicular bisectors. So let's graph them so that we can see this nicely. Y is equal to negative 1, so x plus, was it 3? That's what it was there. Notice that that is going through that negative 2, 3, and 0, 5. That's what we have there. And then my other one was y is equal to 1, so x. And that was, I forget, plus 4. Plus 4. And there we have it. Okay, so now we have that. And so our point of intersection, so notice, so this is where the two lines intersect. It's going to be, okay, so this is negative 1/2, 3 over, so 3.5. That's the point of intersection. All right, so that's our, that's the point that we were looking for. Okay, so that's our circumcenter right there. So we have found that. Now we can find it by equating these two lines. So notice if I put negative x plus 3 equals to x plus 4, it's should give us negative 1/2 as we had on the graph. So bringing this over on the other side, bringing this over to this side, that's going to be 1. Negative 1x minus, so it's going to be negative 2, and indeed, so this is negative 1/2. And then our y value, you can check, okay, by substituting this in here. That's going to be 3.5. All right, so now we know, this is 7 over 2 because that's 3.5. Now we know what our circumcenter is. Now we're supposed to find the equation of a circle. Well, this is our vertex of the circle. That's going to be our vertex. Now we need to find out what the radius is. The radius is going to be from this point to any of the other points that we have. So I'll take the 0, 5. It's probably the easiest one to work with. So let's say 0, 5. That's the easiest one that we can work with. So I need to find the actual distance because that would be the radius of the circle. So let's do that. So what's that distance? Here's our radius. So now we know, okay, so we have our equation of the circle now is, so x minus, okay, this is the x value, right? So it's minus -1/2, that's the squared, plus y minus, that's that, 7/2. Let's put these at 3.5. Now the negative and negative will cancel. So I'm going to put this as just that. This is going to be squared, equals to the radius. So this is the radius squared, right? So if you square the root, so that means this is going to be just 2.5. So that is our equation of the circle. Now let's try to see if we graph it, if it goes through all of those points. So 0.5, -3.5. So x plus 0.5 is going to be squared, plus y is minus 3.5 squared equals to 2.5. And voila! So there we have it. Puts a smile on my face. Okay, so we have all our points. Notice that the circumcenter will actually go through all of those 3 points, and that's the equation of the circle. Now, if you can do that, great on you. All right, so you can understand the actual equations of the circle, and definitely you understand the circumcenter. All right, so that's another example that we knocked off. Last question, question 5. You walk under a bridge that is an arch. The height of the bridge is 15 meters, so that's the height of that arch, I guess. The distance of the arch from one end to the other is 55 meters. What radius does the circle have that the arch is a part of? Round to the 10th if necessary. This is an interesting question, and it brings about, if you may remember, chords on a circle, and then what happens with intersecting chords. So if you've forgotten that, I'll put up a link up above so that you have it there. Let's try to tackle this out and see how this works. Now, it's not going to be a very difficult actually question per se. So what we have is we have something like this. When you have these arches, so if I draw a circle, okay, this way, so what's happening here is that your bridge is basically some portion of a circle like this, something like that. Right, so that's your kind of bridge that you have. That's the arch. And what they're saying is, they're saying that, okay, so you have this, let me just do it correctly. So you have the height, so the height, so from the peak to here, so this right here, so that's your line segment. So they're saying that that is 15 meters. And then they're saying that you have this distance right here. So that distance from there to there. So you have this from here to there. That is equal to 55 meters. And now they're saying is they want to find out what the radius of the circle that creates this arch. All right, so like if we extended it all the way around, we would have obviously a radius. So what happens here, let me remove some of this stuff. Okay, so this is kind of arbitrary for now. So what happens is you have this. You have, this is one chord from here to here. All right, they're intersecting right there. The other chord that you can create to find out the radius is going to be from here to here. That's what you have. So you have two chords. Now, what do we know about two chords? Well, we know from the intersecting chords theorem that you have, if this length is A, this length is B, then this length is C and this length is D. We know that A times B is equal to C times D. That's what we know. if you know that, then you will find the radius, because the arch, so from the top, from the peak to this point right here, if you extend it all the way down, so that C plus that D is basically your diameter, right? So your diameter that you have is just simply C plus D. But the radius is just half of that, right? So that's the radius. And we can find that out. Now, what do we know? Do we know A? Do we know B? Or do we know C? Well, we know C. C is 15 meters. We don't know D. We know A. So A is 55 divided by 2 because it splits it in half. And B is 55 divided by 2. So now all we're doing is we're just solving for D. Once we have D, and let's do that, we'll find D, then we can add C plus D together. So I flip this over on the other side. What I have is, so 55 over 2, so 55 over 2, it's 27.5. So that answered times 27.5 equals. And then, so if I want to solve for D, I'm going to divide this by 15. That's my D. So D is equal to 50.41, I guess it's 6666, and so on. You can round it if you have to on a test or something. And now C and D, so C was 15, plus D, which is 50.416, etc. So my answer plus 15. That's your diameter. This is your diameter. And now your diameter, so that diameter divided by 2 gives you the radius. So the radius is equal to 32.7 meters. I think it said round to the 10th. Yeah, round to the 10th. There you have it. So you can use the intersecting chords theorem to find this neat utilization for bridges and arches. Sometimes you have windows done like that, or whatever it is that you might be doing. And that is it. So torturous test for sure, but it will bring about pretty much everything you needed to know within this particular chapter. Any comments, leave them down. You can let me know which question was the hardest, which made you do a lot of work. Now, obviously, you would need quite a bit of time to try to solve this test. I was explaining it, so, with all the different graphing, it took me much longer than maybe necessary. All right, thanks for watching, everybody. See you in a future video.